Me again. This is the back side of the no calculator quiz review. So you'll notice I'm not using a calculator for any of these, and neither should you. That means that answers that involve square roots will either be whole numbers, they'll be perfect squares, and you can take a square root and get a whole number, or you'll have to simplify them, meaning you break them down into perfect squares and non-perfect squares, and then take a square root of whatever pieces you can. Okay? The one thing I want to point out in this first section is this says to solve. First of all, anywhere you see solve, know that your answer should have a plus or minus in it. Okay, so that's the first thing you should know. And then secondly, I've kind of drilled into your heads that anytime you see solve, you're going to have to use the whole quadratic formula. Well, there are some cases, like these ones over here, that we're not going to need the quadratic formula because we don't have a regular x term, we only have an x squared. So I'm going to be able to solve just with a square root somewhere in the problem. But if you look at the ones over on the right, numbers 19 and 20, those ones are going to be a little more complex. Okay? So like for example, number 16 here, x squared equals negative 64. I'm just going to take a square root on each side, and I'm going to say x equals plus or minus, square root of 64 is 8, and then because it's negative, we make it an 8i. So x equals plus or minus 8i. Now, I had a lot of questions on 17 today, and I had some people trying to put it in quadratic formula. It's not that it's wrong to put one like this into quadratic formula. It would technically work if you just made b a 0, but that's going to give you really terrible numbers for quadratic formula, numbers that I wouldn't expect you to be able to do by yourself. So there's got to be an easier way, and there is. I would divide both sides by 16. Now, some of you are screaming at me right now that I can't actually divide those two, not without a calculator, okay? I can just leave it like a fraction like that, negative 25 over 16. So now I have x squared equals this. From here, I am going to take a square root, okay? And when you take a square root of a fraction, you're really taking the square root of the top and the square root of the bottom separately. So square root of negative 25 is 5i, and square root of 16 is 4. And then because this is solving, because I'm looking for values of x, I do need a plus or minus in front of that. So I'm just going to leave it as plus or minus 5i over 4. Okay. So again, if you've got numbers that don't divide nicely, just leave them in fraction form. Okay, you don't have to divide everything out. You can leave them as fractions and work with them as fractions. So number 18, going to work kind of similar here. I would add 5 to both sides. I end up with 2x squared equals negative 98. Divide by 2, divide by 2. And I've got x equals negative 49. Oh, I'm sorry, x squared equals negative 49. Okay, and then I can take a square root on both sides, which leaves me with plus or minus, because I'm solving, square root of negative 49 should be 7i. I forgot to circle my answer back here, so that's my answer for that one. This is my answer for this one. Okay, so now when we get to 19 and 20, these ones are a little different. These ones do have an x and an x squared in them, so I am going to have to use quadratic formula. Excuse me. So before I can use quadratic formula, I need everything moved to one side. I'm going to do this all in one step and hope that it doesn't confuse you. So I'm going to subtract 4x, and I'm also going to add 25, and my plus 25 is going to just kind of tack onto the end here. So what that's going to give me total is x squared, negative 2x minus 4x is negative 6x, and then plus 25 equals 0. Okay? Now I'm going to go with quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, and I wish I had left myself a little space above this, but normally from here, if I'm going without a calculator, I calculate this part, and I say, all right, negative 6 squared, that's 36. And then here, 4 times 1 times 25 is 100. And then this says 36 minus 100, okay, because of this 1 minus sign. So that's going to come out negative. And so I'm going to end up with this, 6 plus or minus the square root of negative 64 all over 2. Okay, I'm just going to kind of work down the side here, and then I'll keep this problem over this way. Square root of negative 64 then, again, you don't have to write it this way, but remember this is really negative 1 times 64, square root and square root, okay? So this is an 8 and this is an I. And again, maybe you didn't need to write that. I haven't done that for all the other problems. I've just said square root of negative 64 is 8I, but I just wanted to show you how we were thinking about it. This would give me 6 plus or minus 8I over 2. And then you'll notice what we're left with there looks just like these ones we did back here, like number 6, where we did the square root and then we divided. That's the exact same thing we're doing here. We took the square root of negative 64, got 8I, and then we're dividing by 2. So 6 over 2, 8I over 2, that's going to give me 3 plus 4I. Oh, and that's it. Sorry, it would be plus or minus there in the middle. Got distracted looking at something else. But so 6 over 2 makes 3, 8I over 2 makes 4I, and then that should be a plus or minus in the middle, and then this is your final answer. So let's try that next one. That next one, we want to move the 4x to the other side. So add 4x over here. So we end up with 1/2 x squared plus 4x plus 14 equals 0. Okay. Now to solve, I'm going to say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1/2. Okay. So again, just like before, I would start here and I would say 4 squared is 16. And then here I have just one minus sign, so I know it's going to end up being a minus. 4 times 1/2 is 2, and 2 times 14 is 28. So I end up with 16 minus 28, which is negative 12. So now I have x equals negative 4 plus or minus the square root of negative 12 over 2 times 1/2 is just 1. Okay, at least that's kind of nice. Okay, square root of negative 12, that does not break down nicely. Okay, so I'm going to split that up. I'm going to make that a square root of negative 1. And then I'm going to look for a perfect square that goes into 12, and it's 4, and then square root of 3. So I've got negative 1, 4, and 3 to make negative 12. And again, my whole rationale there is I need a perfect square in that list somewhere so that I can actually take a square root. So I'm going to end up with negative 4 plus or minus 2i square root of 3, because square root of 4 gives me 2. The I came from the negative 1, and then square root of 3 is there. And there is your final answer. Okay, we made it. Got just a couple more left to go. We made it through the solving section. So, okay. Number 21. I just want you to notice that this question asks how many. Anytime you see how many, you're going to be using the discriminant, which is b squared, so that'd be negative 7 squared minus 4 times a times c. Okay. For our purposes, let's see. This is 49. And here I have a minus and a minus, so I know this is going to end up being positive. And then 4 times 2 times 4, I think it's 32. Yep. And then 49 plus 32, let's see, is 81. Okay, 9 plus 2 is 11, so carry the 1, 1 and 4 and 3 make 8. So this gives me a grand total of 81. Okay, and this tells me, because it's positive, that I have 2 real roots in this problem. Okay. And then question B says if they are, well, not even if they are, I want you to find all roots, whether they're real, imaginary, or whatever. So now when you're finding the roots, that's when we're using quadratic formula. So I'm going to say x equals negative b, so 7, plus or minus the square root of, now the good news is I already have that number, that's my 81, all over 2 times 2. That gives her 7 plus or minus 9i over 4. Now from here, it doesn't really matter what you want to do. Oh gosh, I'm sorry. I don't know what I was thinking. There's no I here because 81 is not negative. Sorry, I'm in my after school slump right now, guys. There would not be an I there because 81 is not negative, so there should not be an I. Okay? From here, I'm slipping a little too far into autopilot here. I can split, so I have 7 plus 9 over 4. And here, 7 minus 9 over 4. I usually tell you to use your brain on these anyway, because you're smarter than your calculator. 7 plus 9 is 16, and 16 over 4 gives you 4. And 7 minus 9 is negative 2, and negative 2 over 4 is negative 1/2. And those are your 2 real roots that you said you'd have. Okay. All right, let's try that again with number 22, and maybe I won't botch it this time. Last one, I can make it through. So same deal. As soon as I see how many, I want to be thinking discriminant. So my discriminant would be 2 squared minus 4 times negative 3 times negative 1. Okay, so this would be a 4. And then I have minus, minus, minus. So grand total, that's all going to be a minus. Okay, 2 negatives make a positive, but then multiply by a third negative, and you're back to negative. And then here, I'm doing 4 times 3 times 1, which is 12. Well, 4 minus 12 is negative 8. So from this one, I would take either one of these responses. You could say there are no real roots. Because your discriminant is negative. Okay? You could also say that that means I have 2 imaginary roots. So when you don't have real roots, you have 2 imaginary roots. Okay? Either one of those responses would be considered correct. Now, notice down here it says find all roots, whether they're real or complex. So I do want to go through the process of finding the roots. I just know that they're going to come out to be imaginary. So that would be negative b, so negative 2, plus or minus the square root of, luckily I already have that, negative 8, all over 2 times my a value here, which is, sorry, negative 3. Okay, I need to break down that negative 8 using perfect squares. So I'm going to call this, I'm going to write it up here. It's a square root of negative 1. And then I'm looking for perfect squares that go into 8. So I'm going to go with 4 and 2. Okay. So I'm left with negative 2 plus or minus 2i square root of 2 over, what do I have here? Negative 6. Okay. And then I can't actually divide these by 6, but I can treat them like fractions. Remember what I really have going on here, and it doesn't matter to me whether you write it like this or not, I really have negative 2 over negative 6 plus or minus 2I square root of 2 over negative 6. Okay, so I would like it if you would reduce these as fractions here, and this makes a positive 1/3 plus, this is also going to make 1/3, so it's just going to be I square root of 2, oh, I'm running out of space, so close, so close, square root of 2 all over 3. Okay, so 1/3 plus or minus, this also becomes like a 1/3, but then you have I square root of 2 up on the top. And this would be your final answer. Okay, those are your complex or your imaginary roots. Okay, all right, sorry if I got a little babbly towards the end there. Like I said, it's my 5 o'clock slump time right now. I hope that that was helpful for your quiz tomorrow. We will certainly go over questions from this tomorrow, but feel free to post comments or email with questions or whatever you want to do.